Up, up, up. Welcome to Vintage Garage. We have another full show today. First we'll complete the rebuild of the motor for the Lola T492 and install it in the car. After that we'll take a field trip to Williams Grove Speedway for the ARDC midget races. That should be a lot of fun. Lastly we'll get out the jet flux system and weld up a crack in the frame of the Lola T492. So stay tuned, we have a lot to do this week. Glad you're here. Last week we disassembled the motor for the Lola T492, and this week we began by installing new main bearings in the block. Normally we remove the crankshaft entirely to change the bearings, but in this case we don't want to take off the front cover to the motor, so we're changing the bearings in place. We pre-lubricate the bearing shells with plain motor oil, and we like to use a plastic mustard bottle to hold the oil. It's soft and won't scratch the journals if we accidentally bump them with the nozzle. Next we install 1/2 of each thrust washer in the center web of the block. We lay the other half of each thrust washer against the center main cap. Each piece has a groove in it to aid in oiling, and the groove goes to the outside of the cap. Then while holding the thrust washers against the cap, we oil the bearing shell and carefully install the center main cap. We tighten each cap firmly. We'll torque all the caps at the end. And then check to make sure the crankshaft rotates freely. Each cap has a number and an arrow that points to the front, and we double check to make sure all 5 of the main bearing caps are installed properly. Next we install 6 specially heat-treated flywheel bolts and tighten them lightly with the butterfly ratchet. We'll torque these later too. We rotate the flywheel to make sure it runs true. Next we lock the flywheel in place and tighten the flywheel bolts with a torque wrench set to 50 foot-pounds. We then torque all 10 bolts holding on the main bearing caps to 65 foot-pounds. Then we install a clutch disc and pressure plate and use the little torque wrench to tighten the clutch bolts to 15 foot-pounds. Next we bolt on the starter and bell housing. As we found last week, the main problem with this motor was all the top piston rings were broken. We carefully remove the second ring from each piston and then the oil rings. We're going to replace the rings with a new set of Hastings piston rings that we bought at Rockville Ring and Bearing. The top ring is a chrome ring. The second ring is a plain cast iron ring, and the oil ring is a 3-piece ring. We use a piston to carefully push one of the new rings into each cylinder bore and carefully measure the ring gap with a feeler gauge at various depths. We use a power wire brush to carefully clean the carbon deposits off the piston crowns. We then carefully install the 3-part oil rings by hand and use the ring expander to install a second ring on each piston. Lastly, we install a chrome top ring and then move the ring gaps to be 120 degrees apart. We like to use a band-type piston ring compressor and then we carefully fit the rod bearing shells in each connecting rod. We liberally oil each bearing shell, the piston and cylinder wall, and then insert the piston into the cylinder. We use the wood end of our brass hammer to gently push the piston into place, leaving the ring compressor behind. Around to the other side of the motor, we install the other half of the rod bearing and screw down the cap. We gently tighten the big end bolts with a ratchet and then torque them to 30 foot-pounds. We test rotate the crankshaft after each piston and rod is installed, and again when all 4 are in place. We're ready to install the oil pan, but first we need to make a repair to it. The small mounting tab on the front of the pan that locates the dry sump pump is broken off. We need to weld it back on. First we'll unbolt the tab from the oil pump and then we'll check the fit of the tab on the front of the pan. We built a jig out of a piece of scrap aluminum to hold the tab in place while we weld it to the pan. We use our Jet Flux welder to make a strong weld. After the part is cooled, we remove the aluminum jig. We clean up the area around the weld with a wire brush. We'll touch up the paint on the front of the pan with black engine enamel. Back at the engine, we clean the pan gasket surface with thinner. We're using a pan gasket set. The pan gasket has 6 parts. It has 2 rubber end seals, 2 cork gasket halves, and 2 tiny rubber wedges that seal the area around the rear main cap. We sparingly apply a small drop of 3M trim cement to each end of the cork gasket, and then a few drops along the surface of the block to hold the gasket in place. And then place the gasket. We repeat the process on the other side. We put a dab of cement on each end of the rubber end seals where they meet the cork gasket and install 1 at each end of the block. We wipe down the surface of the pan with thinner and then carefully lower the pan onto the block. We start the pan screws by hand and then tighten them with a ratchet. Now we'll turn over the motor and begin work on the top end. We like to wipe the top of the block with a little bit of lacquer thinner just to remove any kind of glue or other material that was left over from the previous engine builder. We're going to use a Motorcraft head gasket on the motor. This is required by the rules. The head gasket has to be a Ford product. So we'll take it out of its container and we'll position it on top of the block. Generally, we don't use any glue or any other preparation on the head gasket. We just use it as it comes out of the box. We use a single-edge razor blade scraper to carefully clean the carbon deposits and old glue off the surface of the head. We then use the air gun to blow out the combustion chambers. Lastly, we wash the surface of the head with thinner to remove any grease or leftover glue. Then we position the head on top of the block. We're careful to make sure that the head gasket is still in the correct place. One by one, we insert the head bolts by hand and then tighten them lightly with the ratchet. We'll torque the head bolts once the motor is in the car. We'll turn the motor around to get to the other side. And while we're at it, we better put the lifting chain on it. It's starting to get heavy and we want to be careful that it doesn't fall off the bench. Next, we install a distributor. And then we position the camshaft timing belt. There's a small belt tensioner at the front of the block, and we release the bolt to set the tension on the belt and then retighten it. Next, we install a Gilmer belt on the oil pump and then the belt on the water pump, and we're ready to put the motor in the car. We lift the motor off the bench and then pull the bench out from under it. We carefully line up the input shaft of the transaxle with the pilot bushing in the end of the crankshaft to mate the motor to the transaxle. And then we use a wrench on the transaxle nuts to draw the two assemblies together. We'll also use this opportunity to wash the outside of the transaxle with thinner to clean it up. Then we simply roll the front half of the chassis back to the rear and bolt the front chassis to the rear chassis. We install a bolt in the top of the rear shock and then install the rear trailing links. Lastly, we install the motor mounts on each side between the engine block and the chassis. We can now remove the lowering chain as the motor is now installed in the chassis. We finish the installation by torquing the head bolts to 45 foot-pounds. After we test run the motor, we'll retorque the head bolts to 75 foot-pounds. It sure is great to have the motor back in the Lola. We're looking forward to testing it next week at Mosport. Next, we'll take a break and head up to Williams Grove Speedway in Williams Grove, Pennsylvania. The ARDC midgets are in town tonight. It should be a lot of fun. It's a beautiful afternoon as we arrive at Williams Grove Speedway, and we're looking forward to the ARDC midget races this evening. The track crew is putting the finishing touches on the well-groomed track surface. Back in the pits, there's a huge collection of ARDC midgets. Let's go have a look at them. This is the number 4 Brayton Stealth, the Mark Freeland. Next to Mark is the number 72 Gertie Stealth of Kathy Kurtz. Malcolm the dog looks on as Jeff Coons works on a rear tire of the number 72. Next door is the number 75 Pontiac Hawk of Fred Shell. Next to Fred is the number 70 VW Challenger of Fremont Dickerman. The number 99 is the Area Stealth of Scott Zip. This is the number 91 Fontana Hawk of Gary Haldeman. The number 6 Gertie-powered midget of Ed Steinley Jr. is ready to go. Next to Ed is the number 88 Pontiac Beast of Frank Fiore Jr. Last year's track champion Ray Bull relaxes next to his number 1 Brayton Beast. The number 2 is the Gertie Stealth of Mark Daly. This is the Gertie Blair of Lou Blair. Next to Lou is the number 55 Gertie Ellis of Steve Craig. This is the Fontana Bossler of Brian Kobelarts. Next to Brian is the 09 of Scott Lawrence. Last on the row is the number 28 Chevy 2 Stealth of Brian Succi. Across the main row are the number 25 and 21 Snyder Beasts of Dwayne and Randy Mosteller.
Track is open for engine heat. Push trucks to the pit, please.
The water truck returns to the pits as the ARDC midgets go out for warm-ups, and the push trucks line up behind them. Brian Kobelarts is first out, followed by Ray Bull. We'll cross the pedestrian bridge and watch the warm-ups from inside the track. Each car makes a couple of laps, and then they return to the pits outside of turn 2. Ed Steinley Jr. finishes his warm-ups, as does Sean Burke in the number 54 Chevy 2D&G. The sun is pretty well set, and it's time for the first ARDC midget heat. Several sprint car heats have just concluded and have worked the dirt track into a smooth and shiny surface. The pace car heads out on the track to form up the midgets. Brian Succi is on the pole with Fremont Dickerman outside on the front row. The cars look well lined up. I think we'll have a start this time. Walt Sturley jumps out to an early lead, but the 8-lap heat race is won by Mark Freeland, followed in second by Ray Bull, and third is Steve Buckwalter. Next up is the second ARDC heat race, and the cars take to the track. The pace car leads the field around. Brian Kobelarts is on the pole, with Mark Daly on the outside front row. Mark Daly takes the lead on lap 1 and leads wire to wire, followed at the end by Ed Steinley Jr., Steve Craig, and Brian Kobelarts. After the two midget heats, The crews ready the cars for the feature race. The number 72 gets a fresh load of fuel. While other crews make minor adjustments or stand pat. We'll head up to the third turn for the ARDC feature race.
Front row, number 49 Brian Kovalars, number 70 Fremont Dickerman. Row 2, number 2 Mark Daly, number 6 Ed Stodley. Row 3, 42W Walt Sterling, 55 Steve Craig. Row 4, number 91 Gary Holterman, number 4 Mark Freeland. Row 5, 21 Randy Mosteller, number 5 Steve Bunwalter. Row 6, 72 Kathy Kurtz, number 1 Ray Bull. Row 7, number 33 Lou Blair, 54 Sean Burke. Row 8, 75 Fred Shell, number 28 Brian Succi. Row 9, 99 Scott Zip, 09 Scott Lawrence. Starting 19th, number 88, Frank Fiore.
The 20-lap race was a great battle between Mark Daly and Ray Bull. But at the end, Mark Daly was the winner, followed by Ray Bull, Ed Steinley Jr., and Mark Freeland. The sprint car rigs begin to leave as Mark Daly is interviewed in Victory Lane.
I want you to welcome to Victory Lane at Williams Grove Speedway, Mark Daly. Congratulations, Mark. Thank you.
After his interview, Mark returns to the pits and receives the congratulations of his crew. It's now Sunday and we have time for one more project this week. We want to fix a crack in the frame of the Lola that we found when we took the motor out of the car. We think this brace made out of formed sheet metal is a factory original part, and it's been repaired many times. We need to replace the whole brace. We'll start by putting a scrap piece of aluminum against the body to protect the body from our torch. Since the brace was attached to the chassis with a jet flux machine using a bronze rod, we can carefully heat the filler material and remove the plate with no damage to the frame. We use a junk screwdriver to lift the brace as we heat the filler material. We then use a grinder to remove any excess filler material. Over at the bench, we can get a good look at the brace. Over at this side, there's a big crack and a piece missing. At this end, someone has welded on a rectangular patch. The toughest part of reproducing this piece will be to put this raised lip on both of the large circular holes. We start by tracing the part on a fresh piece of sheet steel. We then use the throatless shear to cut the side lines. That looks pretty good. We cut the large holes in the sheet with a pair of snips and then take the part over to our press to form the rounded lips on each hole. We made a die out of a couple of bearing races that were about the right diameter and used a big socket to push one of the races inside of the other. Gee, that came out great. Next, we form the lip on each end with the sheet metal brake. Those bends came out great too. Now we can fit the part on the chassis. We use a tape measure to position the brace to match the location of its twin on the left side of the car. After jet flux welding the brace into place, we apply several coats of 2-part primer using a small Badger airbrush. After the primer is dried, we apply several coats of gray DuPont Chroma 1 to finish the job. After the paint dries, we fit the exhaust headers to the motor and then the carburetor and intake manifold to the head. We'll bolt everything up and the car will be ready for Mostport. That's it for this week at Vintage Garage. We had a great week and we got a lot accomplished. First, we finished the rebuild of the motor for the Lola T492 and installed it in the car. The trip to Williams Grove was also a lot of fun, and we finally got good weather for the midgets. Lastly, we fixed a crack in the frame of the Lola using the Jet Flux system. That was a satisfying job and it came out great. Next week, we have another full show. We'll take the Lola up to the Varick Vintage Festival at Mostport near Toronto in Ontario, Canada. At Mostport, we'll get a chance to try out our new motor. In addition, we'll have interviews with some of the other drivers, plenty of scenes from around the paddock, and much improved in-car video. So until next time, thanks for coming, keep the shiny side up. We'll see you next week from Mostport. If you'd like more information about any of the projects we've worked on today, please visit our website at www.vintagegarage.com. There's a link to our email address on the website. Please email us. We'd like to hear from you. Till next time, keep the shiny side up. Thanks for coming. See you next week.